Good morning, my dears. In this session, we are going to take up another interesting chapter. So, areas related to circles, which is based on the concepts of circles. So, please go through the concepts of circles so that you understand this chapter in a much more easier way. Like I do for every chapter, I have selected all possible notes along with the great explanations for everything. You will have a lot of interesting formulas, models of questions as well. So let's go to the session. Welcome to this session. We are going to see areas related to circles in this session. So very interesting chapter, very interesting formulas and all are there. I have given everything. So let's go to the session now. So you have introduction and important formulas I have given, and then useful problem solving techniques like I give for every chapter. I have also given useful PhDs. So here first you have to know what is sector. Sector and a segment, these two are the main topics in this lesson. So you just have to know what is the difference between sector and a segment. So I have illustrated with the help of the diagram here. So see here the definition: the portion of the circular region enclosed by two radii. What are the radii here? OA and OB. So the portion of the circular region enclosed by the two radii and the corresponding arc APB. AB is the arc. So OAPB is the sector, and this sector it's very small, you can see. So it is called a minor sector. So the remaining portion in the circle apart from the minor sector is nothing but the major sector. So this is the thing. This is the easier way to understand. So OAPB, OA and OB are the radii, and this is the arc. So this portion is the minor sector, and the remaining portion in the circle is major sector. So OAPB minor, OAQB major, AOB, this angle. AOB is nothing but the angle in the sector, and 360 minus, because a complete angle in a circle is 360 degree. 360 minus this angle will give you the angle in a major sector. So that's it with regards to sector. Now we will understand segment. So segment, you can see portion of the circular region enclosed between the chord. AB here is a chord. So enclosed between the chord and the arc. Enclosed between the chord and the arc. So APB is the minor segment as it is very small, and the remaining portion in the circle other than the minor segment is a major segment. So a very simple way you can understand. APB is the minor segment, and the remaining portion, what is that portion? AQB is nothing but the major segment. So now you have all the important formulas I have given. Sector of a circle, we have now seen what is minor sector, what is major sector. So area of a minor sector is theta by 360 into pi r square. Theta can be any angle, and area of a major sector is you just have to remember this formula: 360 minus theta by 360 into pi r square. So if you remember this formula, you will be able to solve it. So and then length of the arc they will be asking. So length of the arc of the sector, you have to know this formula: theta by 360 into 2 pi r. And also they will be asking you perimeter of the sector. So theta by 180 into pi r plus 2r. So this is a formula for finding out the perimeter of the sector. And next comes segment. We already saw the definition of a segment, and now comes the area of minor segment. This is a formula: theta by 360 into pi r square minus half r square sin theta. So this is a formula for area for finding minor segment. And area of finding major segment, you just have to subtract this entire thing from the area of the circle, which is pi r square. So area of the major segment is pi r square minus all these things put together: theta by 360 into pi r square minus half r square sin theta. So you will be given the respective values of theta and r. So using that, you have to substitute it here to find out the area of minor segment. Similarly, you have to substitute it here to find the area of the major segment. Now next comes the basics, complete basics. Circle, area of the circle is pi r square. Circumference of the circle, which is also the same as perimeter, which is 2 pi r. And for semicircle, area is nothing but half of the circle, half of the area of the circle, which is half pi r square. Perimeter of a semicircle, the questions can be asked. So that is pi r plus 2r. You just have to divide it with 2. You just have to divide this with 2. You get pi r and add diameter to it. So pi r plus 2r. That will be because diameter is twice the radius. So you have to divide this with 2 and then add 2r to it to get the perimeter of a semicircle. And again, I have given some useful problem solving techniques. Distance moved by a wheel in one revolution. So that is distance moved by a wheel in one revolution. So that is equal to the circumference of the wheel, and number of revolutions made by a wheel in 1 minute. That is, you have to use this formula: distance moved in 1 minute divided by the circumference. And next is area of quadrant of a circle. So you know the quadrants, right? 4 quadrants. So that is area of a circle divided with 4. Simple. 1 by 4 into pi r square. You can also do it you can also remember it in another way, because angle in a semicircle is 90. You have to apply this in this formula: 90 by 360 into pi r square. So 90 and 360 will be 4 times, so 1 by 4 into pi r square. Or otherwise, if you remember the formula, it's well and good. So it is 1 by 4 pi r square. Length of a minute hand of a clock, very important. I have selected one question and then I have solved. Length of a minute hand of a clock, they will be given 6 centimeters. Now they are asking you to find the area swept by it when it moves from 7:05 to 7:40 p.m. See, 7:05 to 7:40, the time difference is 35 minutes. So in 1 minute it will move 360 divided by 60, because 360 degree is the complete angle. So complete angle is 360 divided by 60. That is 6 degree. 1 minute it will move 6 degrees. So here it is 35 degree. So here it is 35 degree. For 35 degree it will move 35 into 6, which is 210. Now you know the angle 210, and you can apply it in that formula. This is the radius. So theta by 360 into pi r square. Theta is 210. 210 by 360 into pi. R is 6. Substitute it here. You simplify, you get this answer. With this, minute hand sweeps 6 degrees of area in 1 minute. So for 5 minutes it is 30. For 10 minutes it is 60. Like that easily you can do. You can remember these things very easily, and then you can do the calculation in a very simple way. I hope this video was very useful for you, and now let's meet in yet another interesting session. Thank you.